All right, so now we're going to come to an equation for administering a bolus of a medication. All right, so a bolus is going to be administered all at once. All right, if we compared that to an infusion, that would be over time. So you have, in real life, you have an example of a bolus of a product and an infusion of a product. So if you were to ingest a coffee bean, that would be the same as a bolus. However, if you crush those coffee beans up and you add them to a cup of coffee, that would be an infusion. And if you had 100 beans of coffee in 100 milliliters of water, you would know that there is one coffee bean for every 1 milliliter of water in your cup of coffee. All right, so that would be your infusion, because you're drinking it over time as opposed to chewing and swallowing up this coffee bean all at once. All right, so if you chewed up one coffee bean, or you drank 1 milliliter of fluid that had one coffee bean ground up in it, it would be the same dose administered differently. That's all, okay? So when we give a bolus, we're basically going to be figuring out what fraction of the container of drug we're giving so that we equal the right dose. All right? So we're going to use the box method, and the box method is going to be the dose ordered or the dose desired. So we'll just say the dose. All right? So if you want to give 2 milligrams or 5 milligrams, all right? So the dose to administer. All right? And that's how much we want to give of a drug. But we're going to be pulling it out of a container that might have more than what we want to give in it. So we need to know the total amount in the container. Right? So usually when we give a drug, it's going to be in milligrams, or when we give a bolus, okay? At any rate, the unit of measure denoted here is going to be a dry weight unit of measure. All right? And since those two are the same, they'll cancel each other out when we get our answer. Then, in addition to that, we know that the container of drug is going to tell us how many milligrams of drug are dissolved in the water that's in that bottle, but we also need to know the total volume of the liquid in the container. And that is going to be, again, in milliliters. And then we always put 1 to hold our place. So if we had a scenario and the question was, you have a container that has 20 milligrams in it, and you're going to give 10 milligrams to your patient, and that container has 20 milligrams, which we know is the total drug in the container, and we're supposed to give 10 of that 20 milligrams, and we know that the 20 milligrams comes packaged in 10 milliliters of fluid. The answer is going to be how many milliliters of fluid are we going to administer so that we're sure to give 10 milligrams. Put our 1 there to hold our place, and then we can do the math. We can either multiply straight across this way and multiply straight across this way, and we'll end up with a fraction, and then we'll divide the top number by the bottom number, or, and let's do it that way to start with. Okay, we'll say 120, so 100 divided by 20 equals 5. So we know that if we give 5 milliliters of fluid, there's going to be 10 milligrams of drug mixed in there. Now if we wanted to let the numbers cancel each other out instead to arrive at our answer, there's a couple ways we could do that. There's my cursor. All right, so we could either reduce the numbers as best we can. We can either do it by just getting rid of the zeros, which is pretty easy. So we could say this 0 can cancel out either this 0 or that 0. Either one is fine. We'll say this one. All right. So 1 times 10 equals 10. And then 2 times 1 equals 2. And then we know that 10 divided by 2 equals 5, and we still end up with the same answer, 5 milliliters. Okay, so that's going to be how we determine a bolus.